The payback period is a financial metric used to evaluate the time it takes for an investment or project to recoup its initial cost. It is the amount of time required to recover the initial investment through cash inflows generated by the project. A shorter payback period is generally considered more favorable as it indicates that the investment is generating returns more quickly. To calculate the payback period, you divide the initial investment by the annual cash flows generated by the project. The payback period is expressed in terms of years. Let's discuss an example of how to calculate the payback period. You'll get a question with a fixed table similar to the one mentioned on this slide. But before we go ahead solving for the answer, let's observe the two projects first. In the table, you will notice two projects, Project A and B, both requiring an initial investment of $10,000. You will also notice that while Project A generates uneven amounts of annual cash inflows, the Project B is generating the same amount of cash inflows annually. When calculating payback for both the projects, different formulas will be used to calculate the payback period. To calculate payback period of Project B, as this is the easiest to understand and remember, this project has equal cash inflows being generated annually, and we will calculate the payback period using the formula payback period equals investment divided by annual cash savings. Putting in the values, you get a payback period of 4 years for Project B, which implies that Project B will be able to recover the amount of investment in 4 years and will be in profit after the 5th year. Payback period for Project A can be calculated using the formula complete years plus fraction. Fraction is where you will have to look at the table very closely. Now, a person with a good background in simple mathematics would notice easily that if you simply add the cash inflows annually, sometimes in year 3, the project will be able to not only pay off the initial cost of investment, but also start earning profit. Let's simplify this for all to understand. Either you make a table for yourself as given in the slide, or you do a mental calculation. It helps to make a table and remove any risks involved, plus you may be mentally tired, so it is always good to be safe. Each and every right answer to the question in the exam will matter. So if I were you, I would make a table. So you'll make 3 columns, one for the years, next column for the annual corresponding cash inflows denoted as amount received, and the third one will be called amount required. Amount required is what you should be careful while filling out for values. For year 1, Project A, we see the project is expecting a cash inflow of $3,000 against the invested amount of $10,000. This implies that $7,000 is still required for the project to pay back the amount invested, which will be your first entry in the third column. In the beginning of year 2, the amount required was $7,000 carried forward from year 1, but the project anticipated a cash inflow of $5,000, so at the end of year 2, the amount required by the Project A to pay back the invested amount would be $2,000. Year 3 is where it gets interesting, and this is also where you get the concept of fraction. Year 3 is where by merely looking at your calculations, you would know that Project A will not only pay back the initial cost of investment, but will also generate a profit amount for the organization. This is where you will draw a dotted line like the one mentioned on the table to calculate for the fraction, and you will use the formula amount required divided by amount received. So 2000 divided by 4000 gives you 0.5. That will be added to the number of years, which is 2. Will give you a payback period of 2.5 years. The negative sign against the amount required starting from year 3 also indicates that you will now have to calculate the fraction amount at this particular point. See you in the next lecture.